The first question of this problem is whether the additive group of modulo 6, of integers modulo 6, is a cyclic group. And if so, we have to write down all its generators. And if not, what is the element that has the highest order, right? Well, this second question makes no sense because the answer to the first one is yes. It is a cyclic group. And it's very easy to see that 1 generates the whole group because you start with 1, right? And then 1 plus 1 is 2, 2 plus 1 is 3, 4, 5, and 6, which is 0, modulo 6, right? And so you generate the whole group, okay? So now you know, so the group is cyclic. This is one generator. Now you know that all subgroups of this are of the form 1 to the m. And remember, 1 to the m is just the group generated by m, because it's an additive group here. Okay? And the order of this group will be the order of the group, which is 6, divided by the greatest common divisor between m and 6. Okay? So in order to find another generator of this group, what we have to find is an m such that this is equal to 1, right? Well, this is not true for 2, 3, or 4, because for 2, this is 2. For 3, this is 3. For 4, this is 2 again. So 5 is the only one that has this equal to 1. So 5 is the other generator. So 5 to the m, which is 5. Okay, it's the group generated by, 1 to the 5. Okay, which is the group generated by 5, is another generator, and the reason is obvious because 5 and 1 are the inverse of each other, right? 5 plus 1 is 6, which is 0, modulo 6. So that this is a generator is trivial. You have 5. 5 plus 5 is 10. 10 is 4, modulo 6. 4 plus 5 is 9. 9 is 3, modulo 6. 3 plus 5 is 8, which is 2 modulo 6. And 2 plus 5 is 7, which is 1 modulo 6. And of course, 1 plus 5 is 6, so 0 modulo 6. So you generate the group just in reverse order from this one. Okay. Well, the other elements, of course, have a smaller subgroups. So for instance, you take this one, right? The order of this group would be, this is 2, so there would be 3. And that's it, because you have 2. 2 by 2 is 4, and 4 by 2 is 6, which is 0. Alright? Same as 4, because 4 is the inverse of this element, so it generates exactly the same group, the same subgroup. You have 4 here. 4 plus 4 is 8, which is 2, modulo 6, and 2 plus 4 is 6, which is 0, modulo 6, right? And finally, if you put here 3, you have, this is 3, so 6 divided by 3 is 2. So the group generated by 3, the subgroup has order 2. And of course it does, because you have 3, and 3 plus 3 is 6, so 0, modulo 6. There you go. So this is the summary of the structure of this cyclic group, right? So first is a cyclic group, right? The only generator is 5, because any other number has this denominator here larger than 1, right? So the order of the corresponding subgroup has is smaller, right? If this is not 1, it's smaller. And the only number for which this is 1 is 5, which is the inverse of 1, and of course generate the same group. All the other numbers generate subgroups, proper subgroups of this group.